Alright, so I want us to look at this question and analyze it. A block of mass 10 grams slides on a rough horizontal surface with a velocity of 2 meters per second. If the object comes to rest after traveling a distance of 0.4 meters, this 0.4 meters, calculate the coefficient of kinetic friction between the floor and the block. Hence, G is equals to 10 meters per second squared. That is acceleration due to gravity is given as 10 meters per second squared. But something comes to mind here. What has G got to do with an object experiencing some amount of frictional force with the floor? You see, there's something there. Let's take it again. A block of mass 10 kilograms slides on a rough horizontal surface with a velocity of 2 meters per second. If the object comes to rest after traveling a distance of 0.4 meters, calculate the coefficient of kinetic friction between the floor and the block. And the hint given here is acceleration due to gravity G is 10 meters per second squared. We are to calculate coefficients of kinetic friction. Very, very interesting, right? Now, what we need to do is, first of all, we analyze the question, which we have done already. Let's bring out the data contained in the question. So the first one is mass. Mass M is given as 10 kg. That's the first thing. Mass is given as 10 kg. The second one, or second data contained, is velocity. Velocity is given as 2 meters per second. Is given as 2 meters per second, right? And then we have comes to rest after traveling a distance of 0.4 meters. It means distance is given as 0.4 meters. All right, 0.4 meters. Good. And what next? Calculate the coefficient of kinetic friction. So mu is represented by mu k, and it's u unknown. Okay? Mu here is unknown. So we are looking for coefficient of kinetic friction in this question. Now we have successfully identified the information contained in the question. The next thing we need to do is to ask ourselves which of the equation of motion or which of the formula as described in the topic friction can be used to solve this and find this value. So that's the first thing. Now let's look at this. We have our data. So we recall that we have equation of motion that has to do with v and x for us to find acceleration. Because if we must find this, we recall that friction is given as F is equal to mu, all right, coefficient of kinetic reaction, UK, and then normal reaction R. Of course, with this, we have started well. Then the next thing we need to do is this. F is given as MA, right? And then R is given as MG. We must take note of this. We must take note of this. Then, if that is the case, we now make mu the coefficient of kinetic, all right, friction, mu k, as to become the subject of the formula, and then it becomes F all over R. Good. From here, if we call this equation number 1, right? Then this is equation number 2, because we are going to make use of this. We can now replace F with MA, we can replace R with MG, right? That is actually where this comes in. That's the reason for giving this in the first place, because of this. Then what do we do now? Well, we don't have acceleration. Can you see? There is acceleration here. We don't have it. What do? We have to find a way. The formula that connects acceleration, distance, and velocity. And that formula is V squared is equal to U, alright, squared plus 2ax, right? V squared is equal to U squared plus 2ax. We have V, alright? But we don't have U because the question says that the object comes to rest. It means the initial velocity U is 0. So here U is 0. We take this, V is given as 2 meters per second. U is equal to 0 meters per second because it comes to rest, right? We have x to be 0.4 meters, right? And then acceleration A is the one we are looking for. That's the one we are looking for. It's the quantity we are looking for. So what do? From there, we can now solve to get that. Where's my duster? Okay. So now we have understood how that works out. The next thing we need to do here is quickly we substitute. We substitute for that. From here, we substitute for A. First of all, we make A the subject and then substitute where necessary. That gives us this. We have 2ax is equals to V squared minus U squared, right? Good. So from here, we divide with 2x, and here we divide with 2x. Good. Now look at this. X, we cancel x. 2, we cancel 2. And we're left with just A is equal to V squared minus U squared all over 2x. Yeah. Look at it very well. Sounds strange, right? But there's no difficulty there. Let's see what we can do. Let's see. We then have A is equal to, for V is 2 squared. Of course, we identify V to be 2 meters per second. It's already there. Okay, 2 meters per second. Look at it here. 2 meters. Meter per second. That's the acceleration. Alright? Okay. So we move on. Minus U, that's the initial velocity, is 0. It's absolutely 0. So we have 0 squared all over. Let's clean this. We don't need this again. All over 2x. Look at this. 2x, and x is 0.4. 0.4. So that is it. Bracket close. This 0.4 is the distance. Look at the distance. And by the time we clear out, if we now clear out very well, we'll now see that A is equal to, this is 4, right? This vanishes and we have 0.8, I think. 2 times this is 8, and then 0, we have 0.8. So further simplification gives us 5. Therefore, it means that acceleration there is given as 5 meters per second squared. Yes, the value of acceleration is just 5 meters per second squared. That's the value here. Now we have found the value of acceleration. We go back to this formula and substitute for this, substitute for mass, and then clear out. So here we are going to clear off this because we need this. Alright? We clear off this and then solve this way to find the coefficient of, rather kinetic of coefficients. Alright? UK is equal to, look at this. For M, Look at our n. We have n, where is it? Mass, yes, 10. So for this we have 10 times, for acceleration we have 5. Alright? For mass again, mass at this point, look at it. We have mass, that is mass this, and then g this. So we have 10 again times g 10. And finally uk is equal to, look at what we are going to have here is 10 times 5 is 50. Alright? 10 times 10 is 100. By the time we cancel out where necessary, we will arrive at the value of UK. Okay? 5 divided itself is 1, 5 divided this is 2, 0.5. So our UK, that is a coefficient of kinetic friction, that's the meaning of UK. Okay? U subscript K is called mu, but I'm calling it U. Mu K, coefficient of kinetic friction, is actually 0.5. 0.5. Okay? So that is how to find solution to something like this. We can actually clean here, right? We can actually clean here to have a very clear view of this. Mu is equal to 0.5. No unit, because coefficient of whether static friction or kinetic friction has no unit. So that is it. So the question is calculate the coefficient of kinetic friction between the floor and the block. It has been calculated, and look at it there. This is the coefficient. Very simple. Alright? So let's see it this way. If we have all that, now we are quite certain that this is this, yes? This cancel this. That's 1, cancel 10, 2, good. So this is half, and half is 0.5. So it's correct. It's absolutely correct. So that is it. If you check very well, that is what it should be. However, if there are steps that are not clear, put it in the comment section. But before I let you go, remember to share with a network. Alright? Give me some thumbs up, some likes. Also, don't forget to make your comments clear. Thank you. I prepare for another class.